Welcome to today's ArXiv CS Digest for March 20th, 2026. We received 544 new computer science papers today across 54 subfields. Let's dive into top picks. Trend 1 of 5, Perception, Mapping, and 3D Simulation. This trend develops advanced methods for perceiving, mapping, and simulating 3D environments and objects for diverse applications. This cluster covers 73 papers. Representative work includes deterministic mode proposals, an efficient alternative to generative sampling for ambiguous segmentation, logger NVS, latent geometry for fully neural real-time novel view synthesis, and HortiMulti, a multi-sensor dataset for localization and mapping in horticultural polytunnels. Trend 2 of 5, Intelligent Agents, Planning and Reasoning. This trend focuses on developing intelligent agents with robust planning and reasoning for autonomous, goal-oriented behavior across diverse tasks. This cluster covers 105 papers. Representative work includes VideoSeek, long-horizon video agent with tool-guided seeking, indoor R2X, indoor robot-to-everything coordination with LLM-driven planning, and taming the long tail, efficient reasoning RL training with adaptive drafter. Trend 3 of 5, AI capabilities, evaluation, and impact. This trend explores AI's expanding capabilities, develops methods for rigorous evaluation, and analyzes its diverse real-world impacts. This cluster covers 126 papers. Representative work includes improving generalization on cybersecurity tasks with multimodal contrastive learning. AI agents can already autonomously perform experimental high-energy physics, and a unified framework to quantify cultural intelligence of AI. Trend 4 of 5, Foundational Models and Applied Systems. This trend integrates foundational models and theoretical frameworks to design, analyze, and enhance various applied systems. This cluster covers 143 papers. Representative work includes mean flow meets control, scaling sample data control for swarms, Kolmogorov-Arnold causal generative models, and just-in-time resale in an ahead-of-time auction, an event study. Trend 5 of 5, Generative Video Models and Evaluation. This trend explores creating and evaluating generative models for video and diverse dynamic visual content. This cluster covers 97 papers. Representative work includes MeCoF Pro, evaluating reasoning coherence in video generative models with text and visual hints, from masks to pixels and meaning. A new taxonomy, benchmark, and metrics for VLM image tampering, and Lumos X. Relate any identities with their attributes for personalized video generation. Up next, our first paper out of 5, Auditing Google's AI Overviews and Featured Snippets. A case study on baby care and pregnancy by Dushing, Hu and Christo Wilson from University of Zurich. Let's break down its key contributions. The paper systematically collects and audits 1,508 real-world baby care and pregnancy-related queries from Google Search. This foundational step establishes a realistic and high-stakes dataset for evaluating AI overviews and featured snippets. A robust evaluation framework is developed to assess AI-generated content across multiple critical quality dimensions. These include answer consistency, relevance, medical safeguards, source categories, and sentiment alignment, providing a comprehensive audit perspective. The framework specifically evaluates the consistency of information presented between AI overviews and featured snippets on the same search result page. This unique comparison highlights potential discrepancies in Google's AI-generated content displays. The methodology includes specific assessments for the presence of medical safeguards and detailed categorization of information sources. This critical analysis identifies gaps in health information quality and potential biases in source types for high-stakes topics. Up next, our second paper out of 5, Advanced Scheduling Strategies for Distributed Quantum Computing Jobs by Gongyu Ni and Michelle Amoretti from Wireless Communications Laboratory, Tyndall National Institute, Dublin, Ireland. Let's break down its key contributions. Introduces heuristic scheduling strategies prioritizing QPU utilization. This ensures efficient allocation of quantum resources, reducing idle time, and improving overall system throughput for distributed quantum jobs. Implements a node selection mechanism considering heterogeneous network connectivity. This enables intelligent routing and placement of quantum jobs, optimizing communication pathways and minimizing latency in diverse distributed quantum environments. proposes an asynchronous node release mechanism, freeing resources immediately upon job completion. This improves resource availability and responsiveness, allowing subsequent jobs to be scheduled faster and enhancing the dynamic efficiency of the quantum network. Develops a scheduling strategy leveraging reinforcement learning with proximal policy optimization, PPO. This adaptive approach learns optimal policies under varying conditions, addressing complex quantum-specific constraints for improved DQC job management. Up next, our third paper out of 5. The residual stream is all you need. On the redundancy of the KV cache and transformer inference by Kaleem Ullah-Qasim and Haiying Zhang from School of Computing and Artificial Intelligence, Southwest Jiaotong University. Let's break down its key contributions. The paper formally proves that the KV cache is entirely redundant, as keys and values are deterministic projections of the residual stream. This fundamental insight challenges the conventional view of the KV cache as essential state. The paper verifies that recomputing keys and values from a single residual vector per token yields bit-identical results. This confirms the residual stream is the sole information-carrying state, satisfying a Markov property. Building on the redundancy proof, the paper introduces KV Direct, a novel bounded memory inference scheme. This system checkpoints compact residual vectors instead of large KV pairs, enabling efficient recomputation on demand. KV Direct significantly reduces peak memory usage compared to standard caches and baselines, maintaining 100% token match. Recomputation is also faster than reading cache tensors at moderate batch sizes. Up next, our fourth paper out of 5, Neural Uncertainty Principle, a unified view of adversarial fragility and LLM hallucination by Dongxiao Zhang and Diyu Meng from Northwest Institute of Nuclear Technology. Let's break down its key contributions. The Neural Uncertainty Principle, NUP, is formalized, revealing a shared geometric origin for adversarial fragility and LLM hallucination. It links input and loss gradient as conjugate observables, providing a unified theoretical framework for reliability. Up next, our fifth paper out of 5, breaking the capability ceiling of LLM post-training by reintroducing Markov states by Yuruin Yuan and Tungyang Xie from UW-Madison. Let's break down its key contributions. This foundational approach defines the state for large language model post-training as the complete concatenation of all preceding actions and tokens. It represents the standard, yet limited, paradigm that the paper aims to improve upon. This introduces the novel concept of deriving compact, informative Markov states from the interaction history, moving beyond simple history concatenation. These states capture essential information for decision-making, addressing the structural bottleneck of current LLMRL. This mechanism integrates the explicitly represented Markov states into the reinforcement learning framework for large language models. By leveraging these structured states, the system aims to reduce sample complexity and enable the discovery of genuinely novel reasoning strategies.